Good morning, welcome to the Lionheart Academy. We're continuing our trigonometry lesson. Today is lesson number 60, complex number. We are on part 4, complex number. Last video we talked about Dumont Theorem and how to raise a power, how to find the power and roots of a complex number. Alright, so today I would like to go ahead and go back and revisit that topic a little bit and then give you some more examples. So let's talk about finding roots of a complex number. So let's go ahead and start with an example here. Well, actually, let's start with review of the Dumont Theorem first. So for any complex number raising to any power, to the n power, it will be r to the n power, cis, and theta. So this is the basic format for the Dumont Theorem. So when we raise a complex number to the power, all we have to do is raise this modulus to the power n, and then multiply its amplitude by n. So that would be how to find the power and n through. But the power is actually very easy, for straightforward. Just reply this when you want to find the power. But when you find the roots, we actually have to be a little bit more. The process is a little bit different. Okay, so let's go ahead and just do an example here, do a few examples. Let's see what we want to do this. Okay, let's go ahead and try this. Let's find y 1 minus I square root 3 to the 5th power. Okay, so first we could go ahead and use rectangular form to do this, perform this operation, but it will be a little bit more complicated. So let's go ahead and identify the radius, the modulus, and the argument, okay, for this z, this complex number. So 1 minus I square root 3, so it's going to be 1 square plus negative square root 3 square, that's x squared plus y squared. So you're going to be square root 1 plus 3, which is going to be 4, so the modulus is going to be 2. And the angle here, as we can see, this angle, this complex number is in quadrant 4, so we're going to do the arctangent. Now because it's in quadrant 4, so we don't really have to worry about the angle. We can go ahead and directly calculate it, and it will give us a negative angle, and we can then add 360 to get back to the correct quadrant angle using the positive angles between 0 and 360 degrees. Now negative square root 3 over 1, so I believe this is going to be equal to a negative 60 degrees. Yep, negative 60 degrees, because as sine, remember sine of 60 degrees is square root 3 over 2, cosine of 60 degrees is 1/2. So if you have a negative square root 3 over 2, that means it's going to be in 4th quadrant, right? So it will be somewhere here, okay? So it should be somewhere here. So this is a negative square root 3, and this will be 1, okay? Negative square root 3 over 1. Alright. So negative 60 degrees, we can go ahead and write it using a coterminal angle by adding 360 degrees. So it will be equivalent to 300 degrees, okay? Negative square root of 2 over 1. 1/2. Actually, this is 1/2, this is 1/2, like that. Square root 3 over 2 and the 1/2. And this will be 1. Alright, so now we know what we are dealing with. Then let's go ahead and write this up. So this is 2 cis 300 degrees, and we are going to raise this to the 5th power. So using a Dumont's formula, so it's going to be 2 to the 5th power, cis 5 times 300 degrees. Okay, so this will be 32 cis 5 times 300 degrees is 1500 degrees. Now we're not going to leave our answers here. We're going to write it in the smallest coterminal angle possible between 0 and 360 degrees. So what do? Is we take 1500, we just subtract 360 from it until we get back to less than 360. So it came out to be 60 degrees. Okay, so 32 cis 60, that will be the final answer. Alright. Alright, let's try another one. Let's try 1 minus I to the 1/4 power. Okay, now when we raise a complex number to 1/4 power, there's only one answer. Okay, we don't have to find 4 roots. But when we find the roots, then we have to find all distinct roots. We'll talk about that roots in the next example here. So we want to find out what is 1 minus I to the 1/4 power. So again, let's go ahead and identify R. Alright, So r is equal to 1 squared plus -1 squared, so it's square root of 2. So r is modulus is square root of 2. The angle theta is, again, this is in arctangent. We're going to do arctangent -1 over 1. So this will be -45 degrees. Okay, it's going to be in quadrant 4. And we can write it using a coterminal angle, which will be 315 degrees. It's a first positive coterminal angle is 315. You add 360 to it. So basically what we're doing is we are taking square root of 2, CIS 315 degrees. We're raising it to the 1/4 power. Okay, 1/4 power, which is 4th root. Finding the but this is not just finding all the 4th roots, it's just finding one of the 4th root. So this will be square root 2 to the 1/4 power, CIS 1/4 times 315 degrees. Alright, let's go ahead and take it out. Go ahead and clarify it. Now, square root 2 to the square root 2 means 2 to the 1/2 power. So 2 to the 1/2 to the power to the 1/4 power, we can go ahead and combine that a little bit later. We can raise the power to another power. Now, 315 divided by 4, that should be equal to 78.75. So 78.75 degrees. Alright, so this will be 2 to the 1/8 power, the CIS 78.75 degrees. Okay, so that can be an acceptable answer. 2 to the 1/8 power, you can also write it as the 8th root of 2. Okay, 8th root of 2, and we can use calculator to find out the equivalent decimal. Alright, okay, so let's go ahead and try to find the root. Okay, so let's go ahead and find the cube root of, let's go ahead and find the cube root of, let's see, which number should we do? Alright, this is square root 3 minus I. Okay, square root 3 minus I. So now, first thing you have to remember is when you want to find the cube root, every complex number has a number of distinct roots. Okay, so let me write it down. Every complex number except 0 has n distinct nth root. Okay, so if we want to take the cube root of this number, we should have 3 distinct roots. But let's go ahead and take a look and see what happens. Okay, how do we go ahead and do it? But go about doing this. So first of all is convert this kind of rectangular form. Okay, convert this complex number from rectangular form back to polar form. So let's go ahead and do the square root. Okay, so square root 3 square plus -1 square, so that will give us 3 plus 1, so it's square root 4, so that gives us 2. So the modulus 2. Okay, there's no problem there. Now this guy is also in 4th quadrant. Okay, I guess we've been choosing everything in 4th quadrant today. Alright, so let's do y. Y is -1, x is square root 3. Alright, so that means sine value has to do with -1/2, cosine value is square root 3 over 2. So that means this is -30 degrees. Okay, and then the coterminal angle would be 330 degrees. We add 360. Okay, so that means it's 330 degrees. Alright. Alright, so our complex number will look like this: 2 CIS 330 degrees. Now, if we just go ahead and take the cube root or raise this to the 1/3 power, we will only have one root. So the key is to come up with coterminal angles that's equivalent to this number. Okay, and as you can see, I can go ahead and create coterminal angles by just simply adding 360 to 330. So if I do that, it will be 690. If I add one more time, 690 to add 360, you will get 1050. Alright, now how come we only stop at 3? How come we don't keep going? Well, actually we can keep going. Let me just go ahead and demonstrate this to you just a little bit here. Let's go ahead and go all the way to 1410. So I have 4 numbers here. Alright, so let's go ahead, because they are actually all the same number. They just have different amplitude, different arguments here. But they are the same number. They have the same magnitude, they have the same direction, and so they are coterminal. Those angles are coterminal angles, so they are basically the same. So let's go ahead and raise to everything to the 1/3 power. So we're finding the cube roots. We're finding the cube root of this number, and they're all equivalent numbers. Basically, they're the same. So this is going to be 2 to the 1/3 power CIS, and 330, we're going to do 330 divided by 3, so it will be 110 degrees, okay? And this is going to be cube root of 2 CIS, and 690 divided by 3, that will give us 230. Alright, and 2 to the 1/3 power, and then it's going to be 1050 divided by 3, it's going to give us CIS 350. And let's go ahead and do this last one. Okay, I'm doing 4 because I want to show you something. 2 to the 1/3 power CIS. Alright, 1410 divided by 3, that's going to give us 470. But you know this 470 is over 360 again, right? So if we go ahead and do the coterminal angle, this is the same as CIS 110. So as you can see, we got 3 distinct roots. You see, we got 3 distinct roots. Let me go ahead and write it out. These 3 are distinct. They are the roots. They are the cube roots of this 2 CIS 330. They're the distinct cube roots. But if I go to the 4th one, guess what? They start repeating. As you can see, these first 3 roots, they are all within 0. They are all between 0 and 360 degrees, so they are all different. But the next one, the 4th one, if I keep going, I will come back up to repeat the roots. So it shows us that this number only has 3 distinct roots. When we take the cube root, it only has 3 distinct cube roots. Except, of course, if we do 0, 0 doesn't work like that, okay? So you only have 3 distinct cube roots. So this is the way that we want to take any kind of roots, like cube roots. If we want to find cube roots, 4th root, 5th root, however many roots, even square roots. Square roots, you have 2 roots, okay? So this is the pattern that we want to go ahead and use. So let's do one more example here. Let's say we have the problem like this: x cubed plus 8 equal to 0. Okay, so this is an equation that we won't be able to solve, or we won't be able to solve using basic algebra. We have to use polynomials and they're solving polynomial equations. But complex numbers can also help us, because as you probably remember from algebra 2, there could be real roots and there could be complex roots when we solve polynomial equations. And here we are treating this as if we are dealing with this problem within a complex number plane with the complex number system, then we can find all complex roots, because real numbers and imaginary numbers are all complex numbers. So what does this mean? Well, this simple equation means x to the 3rd power equal to -8, right? And so basically, what we're solving is if we want to solve for x, we have to take what? We have to take cube root on both sides of the equation. Is that true? Cube root of -8. So what this means is we need to find the cube root of -8. So this is a problem that we can use what we just learned using Dumont Theorem to help us to find the cube roots of -8. So let's go ahead and convert -8 to complex number in polar form. Okay, this is a complex number in rectangular form, right? -8 plus 0i. There's no I there, so you can see this is a -8 plus 0i. So what's the radius? Okay, well, the radius is -8 squared plus 0 squared, right? So again, it will came out to be 8, right? And what about the angle, theta? Well, it's going to be arctan of 0 divided by -8. But if I remember 0 divided by -8, if I remember -8 is right here, okay, right? -8, this is positive 8, this is -8, that's I, that's negative I direction. So if I go and do the arctangent, if you do arctangent of 0, it will give you 0. But this is clearly not 0 degree, because if you look at the angle, it's between 2nd quadrant and 3rd quadrant. It's actually 180 degrees. So this time, the calculator won't be able to help you with this. You have to go ahead and look at the diagram and understand the concept of arctangent to get the correct angle. So -8. Okay, -8 in rectangular form is the same as 8 CIS 180 in polar form. Okay, a CIS 180 in polar form. So that's the first thing we need to understand. Then, because we're taking cube roots, so we need 3 of them, right? So let's just go ahead and get 3 equivalent coterminal equivalent numbers using coterminal angles. So we add 360 degrees. So 180 plus 360 is 540. 540 plus 360 is 900. So we have 3 numbers that we have to deal with. Alright, so now we're finding the cube roots. So let's go ahead and raise this to 1/3 power. Each of them raised to 1/3 power. So it's a to the 1/3 power. CIS 1/3 times 180 degree, okay? So a to the 1/3 power is simply 2. And 1/3 times 180 is 60 degrees, okay? So the second one is going to be 2 CIS 180 degrees, okay? That's 540 divided by 3. And then the last one will be CIS 300 degrees. Is 2 CIS 300 degrees, 900 divided by 3, or multiplied by 1/3, 300. So those 3 are the answers of our roots. But let's go ahead and graph them a little bit, okay? I want to show you a little bit of what the roots look like, so you can get a little idea. So the roots is 60 degrees, one like this, one like that, and one like this. Alright? Hold on. Try to make it the same length, okay? So this is the point here. This is 60 degrees, right? This is 180 degrees. This is 360 degrees. So those 3 numbers are the roots, are the cube roots of -8. And this number, actually, if you look at this is actually -2, right? Okay, this is 2 CIS. So 2 CIS 60 degrees. Let's go ahead and convert this back. I want to go ahead just to show you a little bit of what's going on here. Alright, so let's convert them back to rectangular form, and I want to show you to see what kind of insight we can see, okay? So 2 CIS 60 is 2 cosine of 60 degrees plus I sine 60 degrees, okay, like that, right? So we can convert them. So cosine 60 degrees is simply 1/2, right? That's 1/2. So it's 2 times 1/2 plus I square root 3 over 2. So this becomes 1 plus I square root 3. Alright, so that is one of the roots for -8. Alright, and 2 CIS 180 degrees is going to be equal to 2 times cosine of 180 degrees plus I sine of 180 degrees. Now, cosine 180 degrees is -1, so this becomes -2, and I sine 180 becomes 0. And we know -2 is the cube root of -8, right? -8, -2 times -2 times -2 is -8, so that is the cube root. But you see, if we just go ahead and take it solve it, you're using a real. If we solve it only using the real numbers solution, we only get -2. We would not get 1 plus I square root 3. Alright, what about this one? The last one, cosine of 300 degrees plus I sine of 300 degrees. So let's go ahead and take a look at this. Cosine of 300 degrees is still 1/2, but I sine of 300 degrees is negative. Okay, negative I square root 3 over 2. So when we multiply by 2, it will become 1 minus I square root 3. 1 minus I square root 3. As you can see, those two numbers, they're complex conjugates, and it makes sense. Okay, it makes sense. So we have 3 roots. We have 1 minus I square root 3, we have -2, and 1 plus I square root 3. And that's all comes from our polar form. Okay, those are the polar form answers in polar form. These are the answers in rectangular form. Alright, so we have done a lot of lessons up to this point. We have done 60 lessons. I believe I covered all the major topics that we need in trigonometry. Usually you need, there are other topics that we have not covered, like hyperbolic functions. We have not talked about that yet, and also some less covered topic like spherical geometry. We have not talked about that, spherical triangles. But for now, I believe this would be sufficient for you to at least start most of the regular high school classes. Okay, regular high school classes about trigonometry. I believe all those topics we have covered, and probably a little bit more. But if you have any questions and comments, or if you'd like to see any other topics discussed that we have not discussed yet, please leave in the comment. Please leave your questions and comments in the comment section below, and I would love to hear from you and to be able to do some other lessons that you might want to see again. And thank you for your viewing, and we hope that this series has been helpful. Now in the future, if I am able to go ahead and do a series on hyperbolic functions, then we'll go ahead and do it and then add it to the trigonometry lessons. And we'll also try to do other series like algebra 2, algebra, and geometry. And then so please come back and visit us. We hopefully will be able to produce more content for you guys. And then thank you. We like to see you again in the future. Bye bye.